Hello. Welcome everyone. So today we are going to solve a problem after a very long time. The problem is related to trees, and the problem name is binary tree zigzag level order traversal. So let's go through this problem once. Here, given the root of a binary tree, return the zigzag level order traversal of its nodes values. That is from left to right, then right to left for the next level and alternate between. So if we look at the example provided over here, we are given a tree. 3's left child is 9, right child is 20, 20's left child is 15, right child is 7. Right, so this is how the tree is presented to us, and finally what we have to return is we have to print the nodes in a certain order, just like zigzag order. Right, so initially we will be printing 3, then we will be going over in this direction, then we will print nodes at this level in the order from right to left, which is 20 and then 9. Then we go to the next level. In this we will be printing the nodes from left to right, which is provided in the question. Like initially we will be printing from left to right, then we will switch the order. That means we will be printing from right to left, and so on and so forth. Right, so this is the final value that we have to return. So if we go via C++, right, so we have to return finally a vector of vector, and in which each individual vector is nothing but the nodes present at a particular level. So the first vector is nothing but the nodes present at level 0. The second element, or the second vector that is present in the our answer vector, is nothing but the nodes present in the level 1. Similarly, the third element in our answer vector will be the nodes present at the second level, right? But the only condition over here is we have to keep in mind the order of the elements present at a particular level. So for problems like these, in which we have to deal with the nodes present at a similar level in the same fashion, right? So we can use the concept of queues in those particular problems. So what we can do is we can continuously enqueue a particular node whenever we are visiting that particular node, right, and keep on populating its left and right childs into the queue. But we have to take a special care over here is that we have to read the elements in reverse order sometimes, basically alternate number of times, right? So let's try to understand this using an example. 1 2 3 4 5 6 and 7, right? So suppose this is the binary tree given to us. So initially we would be printing just 1, and then we would be going from right to left. We would be printing 3 and then 2. We come here, and in this level we will be printing from left to right, which is 4 5 6 and 7, right? So it's a classic example where we can directly use the concept of queues, but we need to be take care that we have to print the nodes in the reverse order sometimes as well, right? So for that, what we can do is we can maintain one flag, suppose a level flag, which is denoting, which can have values, suppose 0 or 1. 0 denotes that the nodes have to be printed from right to left, and 1 denotes that the nodes have at a particular level has to be printed from left to right, right? So let us try to write down the steps that we can follow to solve this particular problem, right? So as you know that in these kind of problems where we have to print the nodes at a particular level using the concept of queues, so that's how we are going to use over here. We can try to create one queue of nothing but the node values. Let's suppose these are tree node, right? Once the queue is created, we can push the root node over here. So in our queue we will be pushing the root node, right? So in at this point of time the size of the queue is nothing but 1. Now what we need to do, we need to uh, run a while loop so that we continue our process till our queue becomes empty, right? Queue.empty is nothing but an STL provided by C++, right? So we will be continuing this particular while loop till our queue is empty. So in this we need to iterate over all the elements present in the queue at this particular point of time. So what is the number of elements present at this particular point of time, which is nothing but the size of the queue, right? So let's keep it in some variable called L, which is nothing but queue.size, right? Because we need to iterate over this queue, let's create the queue over here as well. So currently the queue element is just 1, right? Because we have pushed it already. So I'm going to run a for loop over here, which is nothing but it will start from 0 to L. It will run the number of times the number of elements present in the queue at that particular moment. So currently it has just a single element. So this loop will be running just only once. Right here, what I can do is I can take this particular element and uh, see whether basically like I will keep this variable in a particular temp variable q dot front, right? And we can remove this element from the queue as well. So this element would be removed from the queue and I will be holding this particular value in a temp variable, right? And at this point I need to see what is the value of my this level variable. So I can initialize my level variable by 0, which means that initially I would be going from left to right, sorry, right to left, right? So here I can check if level value is 0, right? uh, yeah, one more thing over here is finally we have to return a vector of vector in C++, right? Let's call it an answer vector. So in this vector, each element would be a vector in itself, right? So for that I need to create one more variable called vector of int v, and that I will need to create inside this for loop, right? So initially if the level is 0, and I can initialize this vector v that I have created inside the for loop with the size L. It means that the vector that I'm creating would be of size L, right? So here v of I would be nothing but temp value. So I'm populating this particular vector. So suppose this is the v vector, it will be just having a single value, and in this case it will be 1. But if the level was 1, in that case we will come to it later in the next iteration, right? And after this I already have the temp value over here. I can check if temp left is not null, then I can push temp left as well. Similarly, if temp right is not there, I need to push it. So this was my queue at this point of time. So initially the queue had just element 1 and I had popped the element. So 1 is removed, and this vector v that I am creating inside the for loop, this is having just a single value 1, right? And now I need to push element 2 and 3 into the queue. So the current state of the queue is nothing but this 2 and 3. Now I have reached the end of this for loop. What I need to do over here is I need to change the level value. So level value was initially 0. I need to make it 1 now, right? Why I'm doing this, it will be explained over here. I had skipped a step earlier, right? So the code would be much clearer when I write it in the LeetCode code section, because the handwriting over here is not very proper. But let me just explain you the logic. So here currently the elements in the queue are 2 and 3. So in the second iteration, temp would be nothing but 2, q dot pop. So 2 would be popped, and level value is 1. So in this case, what I need to do is level value is 1. So I have to insert. Basically, I will be creating a new vector v over here when I reach the for loop again, right? And I will be initializing it with the size of L, and L is nothing but over 2 over here, right? So I will be creating a vector of size 2, 0 and 1 are the indexes, and if level is 1, in that case v of L minus I minus 1 would be temp value. So if we go over here, L is 2, L minus I minus 1, L is 2, I is currently 0 and 1, which is nothing but 1. So what is the point of this logic is that we would be populating this vector v in the reverse order, right? So we are not changing the order in which we are pushing the elements into the queue, but what is in our hand is we can change the elements, order of the elements that we are inserting inside our vector v. That's what is being handled over by these two conditions. If level is equal to 0, which means we would be inserting the elements in the same fashion that we are getting into the queue. But if level is equal to 1, which that denotes that we would, whatever the order of the elements is present in the queue, we would be inserting the opposite order into the vector v. Let me try to code this. I think things would be much clearer, and it's getting confusing via this approach. So finally what we have to return is vector of vector, and let's call it answer vector, right? Okay, yeah. So the precondition I can mention is if root is null, I can directly return answer vector, which would be empty. And then I need to create a queue, queue STL I'm going to use. Let's call it queue, right? And I'm going to instantiate this queue by pushing the root element into the queue. And I'm going to create one bool variable level, which is initialized to 0. This bool variable is denoting the order in which we need to populate our internal vector. Here by internal vector I mean this vector, which will be created inside for loop every time. Right, bool level is equal to initialize to 0, and I can just write a while loop, and we need to run this while loop till our queue becomes empty. Right, and what else we need to do over here is I need to get the current size of our queue. Let's call it variable, let's call it size only. If it is not a keyword in C++, let's try queue dot size. And what else we need to do? Nothing else, I think. So but we also need to create one variable vector as well, vector of int v, and that size would be nothing but size, correct? And we are going to write a for loop size number of times. Basically we will be running this loop the number of times the number of elements are present in the queue currently, right? So I'm going to create one temp variable, and that would hold the front element of the queue, and I'm going to pop it. What next we need to do is we can check what is the value of the level flag. If level currently would be 0, in that case we would be have to populate the elements from so what is the order? 29. So firstly we need to go from right to left, right? Let's see it. Let's see, no issues. We will change the code. If level is the case, then vector of I would be temp value, else we need to populate the vector in the reverse order. That is, we will be populating the last element of the vector first, which is size minus I minus 1, which is temp val. Right, this is one thing, and after that I need to check if temp left is not null, then I need to push it as well. And same is the case with its right child. Right, once this for loop is terminated, I need to push whatever value is present in like complete vector v into our answer vector. So we will be keep on appending vector v into our answer vector that we have to finally return, this vector v. So we are populating these vectors. This is one v vector, this is one v vector, this is one v vector. Right, answer dot pushback v. And we also need to change the value of level flag. So level is equal to not of level. So if it is 0, then it becomes 1. If it is 1, it becomes 0. So we are kind of swapping the values. Not swapping, basically alternating the values between 0 and 1. Once this is outer for loop is also terminated, I can return my answer vector. Let me clean the code. I hope it runs, but let's see. I think it will print in the reverse order. Yeah, it is printing in the reverse order, so I need to put not condition over here. Let's see. Yeah, this is fine. I'm submitting the code. Let's see. Yeah, I think runtime, memory usage both are fine, 100%, 94%. So I hope the solution is clear. Where is my code? Yeah, I hope the solution is clear. So basically, the approach we have taken over here is that, like, whenever we have to deal with the nodes at present at a particular level in the tree, especially in a binary tree, we can think of the approach using the queues. But here the problem was a bit modified, that we can't directly use a normal queue. We have to write a custom logic where we need to, while putting the elements into the queue, the order of the elements remains same. That is the first, the left child, and then the right child that is present over here. But the way we are reading those nodes, right, node values, that may differ, right? So we are reading the left node first and then the right node. But after reading, where are we inserting that particular node? So that depends on the particular flag. And if the flag value is 0, then we are putting it as it is, that whatever value we are reading, we are putting that in the first, um, basically first position of our vector v. But if it is, the flag value is something else, then we are populating the last position of the vector v. In that way, we are able to handle the left to right and right to left iterations of this particular tree, zigzag level order, right? So I hope the solution is clear, but if you have any queries, please feel free to comment, and yeah, I will be there to answer that. So I will see you next time. Take care and keep on solving another problem. Thank you.